Okay, let's try this one. Solve 6x squared minus 15 equals to negative x. Well, the zero product property only works when you have 0 on one side of the equation. You have to have a product of two numbers equaling to 0. So in order to use that as a technique, this is where the solving by factoring technique comes into play, I need to transfer the negative x to the left side so that it equals to 0. Now here's a mistake I've seen before. If I add x to both sides here to cancel the x, and suppose I wrote down 6x squared minus 15 plus x equals to 0. Alright, this equation is correct. However, if you try to factor this, written in this order, you're going to run into some problems. For one thing, it probably doesn't factor when it should. And for another thing, it's just harder to factor it correctly when it's not written in descending powers. So you want to write that in descending powers. Here's what I mean by that. So I add x to both sides, and I get 6x squared plus x minus 15 equals to 0. So descending powers means I have my highest power. I start with my highest power, 2. Here's my next power is 1. And my last power is actually 0. It's x to the 0. So I got a 2, 1, 0 in terms of exponent powers. That's descending powers. And that's organized in a way that we normally factor. So you're going to have a lot more success if you write it in the correct order. Now as far as factoring this is another one where the leading coefficient is not 1. So it's going to require a little more trial and error than we typically get. I do need my x's. And so let's see, we have to factor 6. And we have to factor 15. And it's unlikely to be 1 times 15, particularly with an x here, 1x, very small number and a coefficient in the middle. So I'm going to go with 3 and 5 as my most likely factor pair on the right side terms. Okay, now is it 1 times 6 or 2 times 3? I'm just going to try 2 and 3. It's probably the one that works. So now I can't put a 3 here because here again we have a 3 and a 3. 3 would be able to factor it out. We can't factor 3 out. So if I'm going to use 2 and 3, it's going to be 2 paired with that 3, and then 3 paired with that 5. Now let's see if that works. My outer terms product would be 10x and 9x, and I could get 1x out of that, provided I subtracted. So if I had a 10x and a minus 9x, that would give me a 1x. And then do I still get negative 15? We do. And we did get 6x squared, so everything's in order. It's factored correctly. Alright, so I'm going to again use the zero product property to break this up. And so I said each factor equals to 0. And we solve each of these little mini equations. So I'm going to add 3 to both sides. 2x equals to 3. And then divide by 2. X would be 3 halves. Here I subtract 5 from both sides. 3x is negative 5. And then divide by 3. So let me consolidate those answers down here. X would be either positive 3 halves or negative 5/3. There we go. So that's there's the 2 answers to that problem. And again, this would be pretty tedious to plug back in here to check, but certainly nothing wrong with that. But I think as a practical note, if you check your factoring, if you're very good at checking your factoring, and if you never screw up these little equations, then you're most likely going to be just fine on this. So okay, I want to work one more problem with you, so I'm going to erase the board. This one's a 4th degree polynomial equation. The term would be quartic equation. Okay, you don't need to know that, but 4th degree. 2x to the 4th minus 6x to the 3rd minus 56x squared. Actually, it turns out that the degree of your polynomial equation, if it equals to 0, usually there are those many answers. In other words, a second degree equation usually has 2 answers. A fourth degree equation usually has 4 answers. And but this one only has 3, as it turns out. So it can have fewer, but no more than the degree of the polynomial. And it would be impossible for a polynomial to have more solutions than a polynomial equation to have more solutions than the degree, but it could have fewer. Well, anyway, let's go about this. And what do you do? Well, let's try factoring again. And I'm looking at this, I'm seeing it has to have a greatest common factor I can take out. We have 2, 6, and 56. I could factor a 2 out. And x to the 4th, x cubed, x squared, we could factor x squared out. So if I factor this out, I'll end up with x squared minus 3x and then minus 28. And that equals to 0. All right, well that's progress, because this looks like something we've been factoring. One of these trinomials, second degree trinomial. So let's see if we can break this up further. I have this 2x squared, we have to keep it. And let's see, I need x times x. And for 28, it's most likely going to be 4 and 7. And it is, because here I've got 7x and 4x, and to get negative 3, I need the larger number to get the negative, negative 7, and then plus 4x is negative 3x, and here is negative 28. Multiply those numbers together. All right, so now I have a product of 3 quantities together equals to 0, and the 0 product property still holds. One of these factors has to be 0. So it's either 2x squared is 0, or x plus 4 could be 0, or x minus 7 could be 0. So there's our possibilities. Now, when x squared equals to 0, x is going to have to be 0. I mean, 0 is the only solution to this little problem here. And from here, if I subtracted 4, x would be negative 4. And here, if I add 7 to both sides, x equals to positive 7. So we have 3 answers. There we go. Anyway, I wanted you to see that factoring applies in a sort of an unlimited sense. If you're able to factor bigger things, then you can still use this technique of solving equations by factoring. All right, well, let's go on to the next video.